Okay, so when we want to draw a tree diagram, what we're going to do is we'll always have different options for our probabilities. So we'll have choice A or choice B. And when we're going to do that, we always split them into branches. So I could have my first option or my second option. Once I've chosen those options, then I have further options. So then there's going to be my next one, and you're going to have an option, and then the next one, and you're going to have the option. So when we have all these different options, the branches of the tree are going to have specific probabilities. So when we have a split in each one, those need to add up to 1. So if I say this probability is going to be 0.7, for example, this one has to be 0.3 because this branch with this branch must add up to 1. The same for this one. So every time I have a new split, so here's a new split and there's a new split, so these branches must add up to 1, and then those branches must add up to 1. So, for example, if this one is 0.4, this one must be 0.6. And if this one is 0.2, then this one must be 0.8. Okay, so we always write whatever we have at the end of the branch, and then you can place your probability on each branch. So you always need to show the thing that you're looking at plus its probability. And the whole tree, when multiplied together, should also be 1. So if you take each branch, so as I go along each branch, I multiply. So splitting the branches, it means I have this or this, so I add. As I go along, it means and, so I have this and that, so I multiply. So when I have each of those multiplied all the way through, so I have A multiplied with C, I have A multiplied with D, B multiplied with E, and B multiplied with F. All of those combined with our multiplying, and if you add them all together, that should mean that the whole tree equals 1. And that's how you know that you've got your splits correctly. So remember, as we go across from there to there, you're going to multiply, and as we split, we're going to add. So if we look at an example, my question says that when Don plays tennis, he has a 65% chance of his first serve going into the correct area of the court. If the first serve goes into the correct area, his chance of winning is 90%. If his first serve does not go into the correct area, then he gets a second serve. And of these, 80% go into the correct area. If the second serve goes into the correct area, his chance of winning the point is 60%. If neither serve goes into the correct area, then he loses. And now we need to draw a tree diagram. So our first little bit of information here is that when he's playing tennis, 65% of his first serves go into the correct area. So that means we're dealing with either it's going in or it's going to go out. So we can draw our first branch that his first serve is going to be in, or his first serve is going to be out. And they say 65% of his first serves go in. So that means this is going to be 0.65. Because remember, percentages, we need to convert to out of 1 instead of out of 100. So if 0.65 go in, and this split must add up to 1, that means this branch is going to be 0.35. Then our next thing says if the first serve goes into the correct areas. So if this one goes in, then his chance of winning the point is 90%. So if it's in, then he's going to either win or he's going to lose. And his chance of winning is 90%. So that means that's 0.9. And if that's 0.9, that means this one must be 0.1. Then it says, if his first serve does not go in, then he gets a second serve. So if he gets a second serve, that means it's going to either go in the second one, or it's going to go out. And it says 80% go into the correct area. So when on a second serve, when it goes in, that means that's going to be 0.8. And because this is 0.8, this branch must be 0.2. And then it says, if the second serve goes in, his chance of winning the point is 60%. So if it goes in, then he's going to either win or he's going to lose. And his chance of winning is 60%, which is 0.6. Which means if this is 0.6, this is going to be 0.4. Then, and it says if neither serve goes into the correct area, then he loses. So that means after the second one, it still went out, then he's going to lose. So if it goes out the second time, it means he's going to win or lose. So his chance of losing is 100% because he will definitely lose, which means that's going to be 1, and his chance of winning is then 0. So we always have to finish it out. If we're not told anything, so like if our final answer means that he definitely loses, don't forget that we can still have 0 and 1, meaning this is the only option for probability, and this will not happen, but we still need to include it in the tree diagram as a whole because it is still part of the whole probability options. So that's how we do a tree diagram. So then if we look at probability in terms of calculating independence. So independence means that our one event and our other event are independent from each other, and that's what we need to look at. So when we're having a probability, two different events are taking place, and we look at if they're independent. And we look at that when we look at the formula that the probability of event A and B is going to equal the probability of event A times the probability of event B. So this may seem a little bit strange because so far whenever you see and, it's meant multiply. But when we're doing this, you cannot simply take A times B on this side. When we're saying A and B, it means event A and event B are happening together. Here, it's just event A, and here it's just event B, and we multiply them. So if we look at an example, so I can show you what I mean. If we see here, in the first one, it says that Rory has 10 cards. 4 of the cards have a 3 printed on them, and 6 of the cards have a 4 printed on them. So he has 3, 3, 3, 3, because he has 4 cards with 3s on them, and then he has 6 cards with 4s on them. So he has 4, 4, 4, 4, 4, and a 4. So those are all his numbered cards. It says he takes 3 cards at random without replacement, and he adds up the numbers on the cards. So he's going to pick cards out of here, he's going to choose 3 of them, and then he's going to add them together. So event R is the sum of the numbers on the 3 cards is 11, and event S is that the number on the first card taken is a 3. And then we need to determine if they're independent. So if we look at the first event, our first event is R. And R says that the sum is going to equal 11. Okay, so he picks his 3 cards and they must add up to 11. So if we look at those cards with the 4s and the 3s, our only options are to have 2 4s and 1 3 to add up to 11, because 4 plus 4 is 8, plus 3 is 11. So we could have 4, 4, 3, but those could also be in every other order, because there could be that, or we could have chosen 3, then 4, then 4, or we could have chosen 4, then 3, then 4. Because remember, order always matters in probability. So if those are our different options, now we can work out the probability for event R. And we can say our probability of each of those, probability of getting a 4 is that there's going to be 6 over 10. Then we chose that without replacement, so we're only left with 9. Then we chose a 4 again, which means that's going to be times by 5 over 9. Then we chose that, so there's only 8 cards left, and then we chose a 3, so that's going to be 4 over 8. Or, so we add the next one, choosing a 3, means it's going to be 4 over 10, times, then choosing a 4 is 6 over 9, and then 5 over 8. Or, so we add, we're going to have 6 over 10 times 4 over 9 times 5 over 8 for our probability. And when you type that into your calculator, you get an overall answer of 1 over 2. So that is the probability of getting R. So now we need to get the probability for event S. So S says that the first card is a 3. So we now simply need to look at just getting a 3 on our first draw. So my probability for S means I've got to look at how many 3s do I have. So I have 1, 2, 3, 4 3s out of a total of 10 cards. So the probability of just getting a 3 is going to be 4 over 10. And then our last thing that we need for independence is R and S together. So now, as I said before, we don't simply just multiply. I need to look at when I have both events together. So both events together say the sum of the cards must equal 11 and the first one must be a 3. So if I look through all of those options, I've got only this one gives us a 3 first, with the sum being 11 of all 3 cards. So basically, for the probability of R and S together, it means it's just the probability of getting the 3 first, and then they're adding up to 11, so then it's a 4, and then it's a 4. So if you look at that, this one is going to say 4 over 10 times 6 over 9 times 5 over 8. And that gives me 1 over 6. So now I have the probability of R, the probability of S, and the probability of R and S. So now I look at my equation. So I say the probability of R and S equals the probability of R times the probability of S. So R and S together is 1 over 6. R by itself is 1 over 2 times S by itself is 4 over 10. And 1 over 2 times 4 over 10 equals 1 over 5. So 1 over 5 does not equal 1 over 6. So we put a line through our equal sign, and we say, therefore, these events are not independent because they do not equal. And that's how we then work out to show our sums. So if we look at the next example that I have, we are told that Q is the event that Nicola throws 2 fair dice and gets the total of 5. S is the event that Nicola throws 2 fair dice and gets 1 low score and 1 high score. The low score is either a 1, 2, or 3, and the high score is either a 4, 5, or 6. And they want to know, are these events independent? So we have event Q, which is that the total is going to be 5. So if we look at our total being 5, okay, you can look at what all our different options are for our dice, or you can put it in a table because we're rolling dice twice. So we have 1, 2, 3, 4, 5, 6. And we have 1, 2, 3, 4, 5, 6. And we're adding them together because when she throws the 2 of them, she gets a total of 5. So if we add all those numbers and we fill in our table, so there, everything added together, and now we simply need to find where the total is 5. So our total being 5, we have 1, 2, 3, 4 5s out of the total of 6 times 6 numbers of 36. So our probability is going to be 4 over 36. Then event S is that she gets 1 low score and 1 high score in each dice. So we've got event S being 1 low and 1 high. So it doesn't tell you the order of whether she must get the low first or the high first, so we need to include that. So when we're working out our probability, we're going to say either she's going to get the low one first and then the high number, or she's going to get the high number first and then the low number. And when she does that, the probability of getting a low number on the dice, there is our numbers 1, 2, or 3 are low. So that is 3 of the numbers out of the 6 sides. So the probability of your low number is going to be 3 over 6. Because there's 3 low numbers out of a total of 6. And then the high numbers is 4, 5, or 6. So those are 3 numbers out of the 6 sides of the dice. So there's 3 over 6. Or the high numbers, there's 3 of them out of the 6 sides. And then the low numbers, 3 of them out of the 6 sides. And we get a final answer there of a half. So then we have to look at when Q and S are together now. So if we have Q and S, it means that the total is 5 and one of the numbers was low and one of the numbers was high. So if we look at where we got 5s, we had 4 and 1, and we had 3 and 2. So 2 and 3 both fall under low because the low score is a 1, 2, or a 3. So there's a 3 and a 2. So both of those are low. But a 4 counts as a high score. So then there's 4, and a 1 counts as a low score. So there we have 1 low and 1 high. So the only options are either a 4 and a 1 or a 1 and a 4. because the other ones don't fit both categories. So to work that out, we're going to say the probability of Q and S means it's going to be the probability of getting a 1 and a 4, or the probability of getting a 4 and a 1, because that's the only ones that fit both criteria. So working out that probability, getting a 1, there's only one side with a 1 on it out of the total of 6 sides. A 4, there's only one of them out of the total of 6. Plus getting a 4, there's 1 out of 6. And getting a 1, there's 1 out of 6. So when we work that out, we get an answer of 1/18. So now we need to work out our independence by saying P, or the probability of Q and S, is going to equal the probability of Q times the probability of S. So Q and S is 1/18, and that's going to equal Q, which we saw over there was 4/36, times S, which is 1/2. And when we type that into our calculator, 4/36 times 1/2 gives us 1/18, and Q and S is 1/18. So that means that equals that. So therefore, they are independent because they equal each other. Okay, so if we look at one more example, I've got two fair 12-sided dice with sides marked 1 all the way to 12 are thrown, and the numbers on the sides which land face down are noted. Events Q and R are as follows. Q is that the product of the two numbers is 24, and R is that both of the numbers are greater than 8. So if we look at all of those numbers, we've got to find which ones of them can be multiplied together to give us the answer of 24, because the product of the two numbers is 24. So if we look at all those numbers, 1 times 12 is not going to work. 2 times 12, though, can give us 24. So we can have 2 and 12 is going to give us 24. And if we carry on going through them, we'll find that we can have 3 and 8 to give us 24. And we'll also find that we'll get 6 and 4 to give us 24. And then obviously we also have the reciprocals of those because order matters. So we could have 12 and 2, 8 and 3, and 4 and 6 for all of our options. And then the second part there says that both of the numbers are greater than 8. So if we look at those possible options, in all of them, none of those options where we have more than 2 of them being greater than 8. There's always one number that's less than 8. So the probability of having R is going to be 0 because none of those numbers are greater than 8 when we have them, when our product is 24. So we can say the probability of Q and R is going to equal 0 because we can't have the product being 24 with both numbers being greater than 8 because that just simply can't happen there. So when we have something like this, when we work out Q and R and the answer is 0, this is because then we can say that the events are mutually exclusive. So when the events are mutually exclusive, it means that the probability of event A and B happening together equal 0. And whenever you have that answer, you can then simply write that these events are mutually exclusive. So besides independence, defined when we have our two events and you make them equal to each event times each other, when you have the two events and they equal 0, that is when there's mutually exclusive. So if you're asked to find mutually exclusive, all you have to do is look at both events together. You don't need to calculate each event separately. You just need to find them together. And if it's 0, it is. And if it has a number or value, then it's not mutually exclusive.